Hi, welcome. In this video, we'll look at the following production function. FLK equals max LK, and what we'll do is the following. We'll look at the short run cost function, which is obtained by minimizing cost with respect to input labor, uh, subject to the constraint that you want to produce y units of output, okay, at the minimum cost. So we'll look at that short run cost function. We'll see, if we minimize the short run cost with respect to fixed factor capital, then what we'll obtain is the long run conditional capital demand function. So we'll see. We'll just verify this, okay, for this particular production function. So we already know that if we minimize WL plus RK with respect to LK, subject to the constraint that we want to produce at least y units of output, we'll obtain the long run conditional labor demand function and long run conditional capital demand function, and if we substitute it back into the cost, we'll obtain the cost function. We have already seen this in one of the earlier videos, okay. So if we substitute the conditional labor demand function and conditional capital demand function into the cost, we'll obtain the cost function. We have seen this in one of the earlier videos, okay. So let's just quickly recall, how it happens. So basically, if you plot the constraint set, this is how it's going to look. Okay, and if W is less than R, then the lowest possible ISO cost curve will look like this, and you will employ only labor. And if W is greater than R, basically if labor is more expensive than the capital, then the lowest possible ISO cost curve will look like this, and you will employ only capital, okay. And if W is equal to R, so basically both are equally expensive, or both costs the same, then the lowest possible ISO cost curve will look like this. Then you can either employ only labor or you can employ only capital, and the magnitude of labor and capital employed in all these cases is either y or 0, okay. So if we just write this, this is how we can write the conditional labor capital demand function, LCKC, and it's a function of W, R, Y, and because there are multiple solutions, so I'm going to use because there is a possibility of multiple solutions, so I'm just going to use belongs to over here, and I'm going to write the set of solutions over here, okay. So if W is less than R, then in that case, you will employ 0 units of labor, you will employ y units of labor and 0 units of capital. And if W is greater than R, then you will employ 0 units of labor and y units of capital. And if W is equal to R, then you're going to employ either y units of labor, 0 units of capital, or 0 units of labor, y units of capital. So this is the solution to the long run cost minimization problem, and the associated cost function is CWRY, which is min of WR times Y, because when W is less than R, you'll employ y units of labor, so the cost will be WY. And when R is less than W, then you'll employ y units of capital, and therefore the cost will be ry. So it is the smaller of the two which is going to be the marginal cost, smaller of wage or the rental rate, which is going to be the marginal cost, and multiplied by the output, okay, y. So this is what we have already seen, okay, and we have also seen how to solve for short run cost minimization problem, which is minimize with respect to L, WL plus RK subject to max LK greater than or equal to Y. And we have already seen that if we solve this problem, then the solution to this problem, which is the short run conditional labor demand function, is a function of WRKY, okay. And in this case, if capital is sufficient to produce y units of output, then you'll employ 0 units of labor. And if capital is insufficient to produce y units of output, then you'll have to employ y units of labor to achieve y unit of output, okay. And the associated short run cost function is therefore, if k is greater than or equal to y, then it is just rk, because you are not employing any labor. And if k is less than y, then it will be the cost of the which it will include the fixed cost, which is rk, and also the additional cost on labor, which is wy. Okay, so this is the cost function, the short run cost function. Now what we are going to do is we'll show that if we'll just verify that if we minimize the short run cost with respect to fixed factor capital, okay. So if you minimize the short run cost with respect to fixed factor capital, what we'll obtain is the long run conditional capital demand function, okay. So we'll just verify this, and then when we plug this back into the short run conditional labor demand function, we'll get back the long run conditional labor demand function. And when we substitute this solution into the short run cost function, we should get the long run cost function. This is what we'll now verify. So let's solve this problem where we'll be minimizing short run cost with respect to the fixed factor capital. Okay, so in order to do that, we'll plot the short run cost function in where we'll put on the vertical axis we'll measure the cost, and on the horizontal axis it will be the choice variable, which is capital. Okay, so let's just do that. Okay, so now let us plot the short run cost. So notice that this is the short run cost function. So this is what we are going to plot now, and this is what we want to minimize, right? So let's just plot this, and let's see where is this function going to take the smallest possible value. So we are doing this for a given level of y. Okay, so let's fix y, okay, because we'll have to compare capital with y, whether capital is greater than y or less than y. Depending on that, the cost will take this expression or this expression. So if capital is greater than or equal to y, then it is rk. So if we plot the cost function, it will be rk like this. So this is rk, and this is the case if k is greater than or equal to y. So this point is included. Okay, and if k is less than y, then it is wy plus rk. So notice that y is fixed, w is fixed, so it is just going to be a parallel shift, you know, by the extent of wy. That's what we are going to get. So now it depends on whether w is greater than r or less than r. The position of the line will depend on how what the case is. So let's consider the case when w is greater than r. Okay, so if w is greater than r, then in that case wy plus rk will look like this. Okay, it's just going to be parallel, and this is your wy. Okay, and notice that this is because this function is rk, right? So at y it takes value ry. Okay, and that is why I said it depends on w and r. So if wy is greater than ry, or basically if w is greater than r, then the line will look like this. Okay, and we'll consider other cases as well. When w is less than r, it will look like this. Okay, because it's a position of wy with ry that we want to compare. Okay, now notice that it is wy plus rk till this point, and here it jumps to this point, and then this is how it's going to look. So can you tell me where is the cost minimum? Where is the short-run cost minimized? If you want to minimize this function, minimize the value of this function with respect to capital, where do you think it's minimized? So notice that it's increasing in this region, and then it drops to this value, and then it goes up, and this value is the lowest possible value that the function takes in the entire real line, right? I mean, ry is the lowest possible value that this particular function takes on the entire real, on the entire r plus. So the optimal choice is, if w is greater than r, is k equal to y. So what we have is kc w r y equals y if w is greater than r. Okay, and if we just do this problem quickly again, for the case when w is less than r, okay, this is the case when w is less than r. Okay, in this case clearly this function takes the minimum value at k equal to 0. Okay, so let's just write that here. Okay, so it is 0 if w is less than r. Okay, and the last possibility is if w is equal to r, and clearly in that case it's just going to take the smallest possible value at 2 points. One is 0 and the other is y. Okay, so just do that yourself. Okay, verify that if w is equal to r, then there are two optimal choices for capital, because in that case the function will look like this, and at both these points the value of the short-run cost is minimum. Okay, so both these values of capital, k equal to 0 and y 0 as well as y, minimizes the short-run cost with respect to capital. Okay, so Now notice that this is exactly what we obtained here, right? I mean, when we solve the long run cost minimization problem, the conditional capital demand function was 0, when w is less than r. So when w is less than r, it is 0. Okay, when w is greater than r, it is y. When w is greater than r, it is y. And when w is equal to r, it can be either 0 or y, and that's exactly what we have over here. Okay, and now let's just substitute it into the short-run conditional labor demand function. Let's see what we are going to obtain. Okay, so hopefully we should get the long-run conditional labor demand function. Okay, so notice that when w is greater than r, okay, so when w is greater than r, then k is y. Okay, and when k is y, L is 0, right? So it is 0 if w is greater than r. Okay, and when w is less than r, k is 0. And when k is 0, then there are two possibilities. Well, y is 0 or y is positive. Okay, so in either case, it will be equal to y, because uh, because uh, because when y is positive, then 0 is less than y. In that case, the labor is y. Okay, and when y is 0, then in that case this case applies, and in that case labor will be 0, which is equal to y. So it is equal to y irrespective of whether this case arise or this case arise. So if w is less than r, labor is y. Okay, and if w is equal to r, then in that case, k can be 0 or y. And when k can be 0 or y, so again, if you see, when k is 0, then labor is y, and when k is y, then labor is 0. So basically, you're going to get both these cases, y comma 0. Okay, and that's exactly what we have over here. When we solve the long run cost minimization problem, that's exactly what we have over here. When w is greater than r, labor is 0. When w is greater than r, labor is 0. When w is less than r, labor is y. When w is less than r, labor is y. And when w is equal to r, then in that case it can be y or 0. And that's exactly what we have over here. It can be either y or 0, okay, depending on the value of the capital. And now we can substitute this into the short-run cost function and see what are we going to obtain, and hopefully we'll obtain the long-run cost function. Okay, so let's consider case by case. So if w is greater than r, then the capital is y. So capital is y, that means this case applies, and when this case applies, it is r times y. So it is r times y, because capital is y, right? So this case applies, so k is y, so the cost is r times y. Okay, and if w is less than r, then capital is 0, and when capital is 0, labor is y. Okay, so capital is 0, labor is y. Then when y is positive, then this case applies. And again, the same logic applies, that if y is 0, then it can be treated in any of these two cases. Irrespective of what happens, your cost will be wy, because this is 0. Okay, okay, and if w is equal to r, you can put it in any of the two cases. It doesn't matter. And you'll get wy. Okay, so notice that this can also be written like this: minimum wr times y. Okay, so that's exactly what we have over here. So if we minimize the short-run cost with respect to fixed factor capital, okay, Then we'll obtain the long run cost minimize solution to the long run cost minimization problems, and we'll also obtain the long run cost function. Okay, and the idea here is straightforward. Basically, what you're doing is, in this particular problem you have solved the problem like this, and by solving the problem this way, you have just changed this, just converted the problem uh, to a problem like this, where you are minimizing in a sequence. I mean, you are first minimizing wl plus rk subject to max lk greater than or equal to y. Okay, first you're solving this problem, which is the short run cost minimization problem, and then whatever objective you obtain, when you just solve this problem, you are minimizing that with respect to capital. So it's just another way of solving the long run cost minimization problem. So it is not surprising that you get uh, the same solution as the one that you obtain by solving the long run cost minimization problem directly. Okay, so we have just verified this. Thank you.